Hey, welcome back to another math video here at Math Rocks with Mr. Cox. As you may have guessed already, this video is all about word problems. And as you can see here in the problem, you're basically kicking a soccer ball. And what happens in this kind of problem is it's going to form the shape of a parabola, aka a quadratic. Whereas this is where the ball starts, it gets kicked in the air, reaches a maximum height somewhere in the middle right here, and then drops back down to earth again. It could also look like this, where maybe in this case it's a half pipe where it's built into the ground, once again in the shape of a parabola, where this is the side of the half pipe, and then it reaches its maximum depth here in the middle and then comes back up again. So that's what we're going to be looking at in this video, is how to create the actual equations that model these parabolas. Let's get it on! As you learn how to write equations for quadratic models, there's a couple of things that you need to consider first. What I've done is I've gone ahead and graphed a couple of parabolas over here. In each case here, they have the exact same x-intercepts. Up here, it would be 2, 0 and 8, 0. And on the second one below, it's also 2, 0 and 8, 0. So one thing that should be fairly obvious by now is, yeah, there's more than one parabola that can share the same x-intercepts. However, they're obviously very different here. And in fact, there actually turns out to be an infinite number of parabolas that have the same x-intercepts. And what makes them unique or different from each other is their a value. In the top parabola, that a value, a multiplier out in front in the equation, is negative 2.5, whereas below it's 1.8. So we can change what that parabola looks like based on the a value that's multiplied out in front. So that's the first thing. The second thing is that if you want to find the vertex, so the vertex up here is 5, 22.5, that's right here. And on the one below, it's 5, negative 16.2. Well, it turns out that the vertex, its x-coordinate is always halfway between the x-coordinates of the x-intercepts. I know that's a mouthful, but let me look at another way here. Our x-coordinates are 2 and 8. Halfway between 2 and 8 is 5. Or you can look at it as the average of 2 and 8. So those are the two things you want to consider as we move forward to learning how to write equations for these quadratic models. We're going to go ahead and look at the first word problem from the introduction. You kick a soccer ball and it travels a horizontal distance of 60 feet and reaches a maximum height of 15 feet. We're going to sketch its path. So I've gone ahead and just drawn a generic little sketch here. We have x as our distance and y would be our height. And what we're going to do is, the plan is, we're going to get some points on that sketch that we've just drawn, and we're also next going to find the value of a. So let's get those points first. So the ball is going to start out here. It's going to reach its maximum height right here in the middle, and that is our vertex. I'm going to go ahead and put a V there. And then it's going to reach back down here at Earth. So our starting point is, if we were going to look at this in terms of coordinates, would be 0, 0. And since we kicked it a distance of 60 feet, over here our other x-intercept is going to be 60, 0. Once we know that, we can now find the coordinates of our vertex. So as I said earlier, that the vertex, the x-coordinate, is always halfway between the x-coordinates of the x-intercepts. Halfway between 0 and 60 would be 30. And then we know that it reached the maximum height of 15 feet. So it's going to be 30, 15. These are the 3 points that we're about to use to go ahead and create our equation. So let's go ahead and set up this first one here. And by the way, this would be what we call the intercept model. So I'm going to write y equals a. We don't know what a is yet. It's going to be some number. But we do know this. Because this is 0 as our x-intercept and this is 60, we can write x minus 0 in our first set of parentheses, and because this one is 60, we can write x minus 60. So from here, what we need to do is we need to figure out this value of a. And the trick is, we've already used 2 points. We've used the x-intercepts. We have yet to use the vertex in here. And what we can do is 30 would be our x and 15 would be our y. We can now go ahead and substitute here And so everywhere we see a y, we're going to put a 15. So that's now going to become 15. A stays alone there, and then x is going to be 30 because that's what it is in the vertex coordinate here. So we're going to say 30 minus 0. And on the second set of parentheses, we're going to say 30 minus 60. From here, what we can do is we can still say 15 equals a. Well, we know 30 minus 0 is just 30, and we know that 30 minus 60 is negative 30. And if you go ahead now and you multiply those together, you're going to get 15 equals a. 30 times negative 30 would be negative 900. Let me go ahead and erase this out here. So I can go ahead and I can write this as negative 900 times a. And then finally, to solve for a, we're going to divide both sides by negative 900. And once we've done that, we're going to wind up with a fraction over here. If you feel like you want to go ahead and change it to decimal, go for it. But I'm just going to leave it as negative 15 over 900. We can actually reduce that. And if we reduce that, it actually becomes negative 1/60. So therefore, our equation that would model this parabola would be y equals negative 1 over 60. And then it would be either x minus 0, or if you prefer just x, I'm going to leave it as x minus 0, and then times the quantity x minus 60. This is once again what we call intercept form. There is a second way you can solve this problem. You get an equation for the parabola modeled here, and how it would work is this. Rather than writing an intercept form, we're going to write it in what's called vertex form. So I'm going to write y equals a, and then what we're going to do is, this is going to be our vertex form that's been discussed in earlier videos. Because our vertex is 30, 15, I'm going to put x minus 30 right here. Inside the parentheses, that's squared, and that's going to be multiplied by a. And then because we have a 15 here, we're going to put a plus 15 here. So once again, this is vertex form. This is not intercept form. Once again, we've already used a point. So since we've already used the vertex, we have to use another point, either 0, 0 or 60, 0 as our x and our y. I'm going to go ahead and use the 60, 0 for fun over here. So y is going to be 0, so I'm going to replace that with 0. A is, we're going to leave that alone. X is 60, so I'm going to write 60 minus 30, quantity squared, plus 15. At this point, what you can do is you can subtract 15 on both sides. So 15 subtract from each side would give us a negative 15 on the left side of the equation. Gone over here. And then 60 minus 30 would be 30, and 30 squared is 900. So this now becomes 900a. And now if we go ahead and divide by 900 on both sides, what you'll notice is we get the exact same value for a. We get negative 15 over 90. And then of course you reduce that down to negative 1 over 60. So if we do vertex form instead of intercept form, it will be y equals negative 1 over 60. And then we have times the quantity, x minus 30, squared, and then a plus 15. So once again, this is vertex form, and it works just as well as the other one. It kind of depends on what information you want to use. If you like what you've seen and heard so far, please like, comment, or subscribe. Thank you, and back to the show. So now you've had a chance to see how to solve and come up with an equation that's either an intercept form or vertex form. And we have a new word problem here, and I'm going to give you a chance to try this problem on your own. And in the setup here is we basically have a half pipe. Because we have a depth of 20 feet and we know it has a width of 50, we'd have 0, 0 and 50, 0 as our width across here at the very top at ground level. Halfway between 0 and 50 would be 25, so that's where I got the 25 from. And then it reaches a depth of 20 feet, which would be negative 20. So what I'm going to do right now is I'm going to have you pause the video, and you can decide, do you want to do this in either vertex form or do you want to do this in intercept form? It really doesn't matter, whichever one you prefer. So go ahead and pause the video right now. All right, so now that you've had a chance to actually work on it, I'm going to have both solutions here for you on whichever method you chose to do. The x-intercepts form is up here. So once again, we're going to be using 0, 0 and 50, 0 up here. So that's where the x minus 0 and x minus 50 comes from. You're going to use the x and the y here. That's our x, that's our y. So y is negative 20, that's why you see negative 20 here, and x would be 25. And you just go ahead and do the math here. You wind up with negative 20 equals negative 625 times a. You wind up with a value of a equals 4 over 125. So that would be your a value, and then you can write the rest of the part out. What will happen if you do vertex form? Very similar. This time, because we're using the vertex, we're going to say x minus 25 in parentheses squared, and then the negative 20 goes outside here. In this case here, I chose to use 50 comma 0. So you can see I have my x and my y up here. So y would be 0 and x is 50. And then we just follow along the math here, adding 20 to both sides, taking 25 squared. You wind up with a being a value of 20 over 625 as a fraction, or 4 over 125 if it's reduced, and there's your equation. So really, no matter which way you decide to do this, you're going to get the same a value. It's just the rest of the part of the equation is going to look a little bit different. But trust me, it is the exact same parabola. All right, well, hope you enjoyed this video, and hope to see you again soon. Thank you.